Good evening, good morning, good day. Hello, 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 everybody. Hello, everybody. Hello, 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 everybody. Hey, hello, guys. Hello, hello. This is your maths gamer person that is basically here to show you guys what needs to be critically taken into consideration as we approach. This is basically 7 days until we write final exams. Yeah, who would have thought? 7 days, guys. 7 beautiful days until we write. So as we are approaching final end of year exams, I'm sure a lot of us are like, I wonder what is going to be the happening for me when it comes to the performance of the you know. So the hope is that we will all do very well in the maths when it comes to exams as they will be written. Okay, hopefully, guys, we can comfortably say that these marks are marks that we can get. You know, very important, very, very important. Okay, that we can say in our hearts that these marks are marks that we can get easily as a grade 12 learner. No fear, no anxiety, no pain. No pain, no gain. Alright. So hopefully question 1, solve for X, the 3 marks. You know, if you are a learner, there's no ways that you can get 0 out of 150 for a paper 1 exam. No ways. No ways at all. So let's just quickly scan through this paper. This is a paper that was written in the May or June rewriting learners that basically are in grade wrote this paper. You know, so 1.1.1 learner and the grade 12 learner. All learners that are in grade 9, 10, 11, and 12 can answer question number 1. Alright, and that is a fact that cannot be denied. In grade 11 can answer 1.1.2, because what do we use when we are answering a question like this to correct to decimal places? What do we use to answer a question that is like this, 1.1.2? We use what, guys? We use A. Anyone wants to comment? When we're answering a question like this, we use the. Okay, let's see if I actually have it here. The dreaded formula sheet. Okay, the welcome formula sheet. Okay, so when we are answering a question like that, 1.1.2, we can use the what? We can use the quadratic formula. There it is, guys. There's the quadratic formula. This can be used when answering question 1.1.2. X is equal to minus p plus minus the square root of p squared minus 4ac over 2a. This can be used to answer this question. Alright? And that's very clear for people. I hope it's clear that we can use this quadratic formula when answering. Okay, you can use this. Then, to 1.1.3, how would we approach this question? This one. 2 to the power x plus 4 plus 2 to the power x is equal to 8,704. How do we answer a question like this? 2 to the power x plus 4 plus 2 to the power x is equal to 8,704. Mind you, that this question, okay, is not the only type of numerical based question we can get when it comes to our exams. Okay, it is not the only type of exponential equation that we can get. But how do we approach this question when we are given this question to answer? Do we know? Can we say? What would we do? Okay, So important to know the procedures to follow when we are answering questions. Okay, so 2 to the power x plus 4 plus 2 to the power x, that means we have two terms in the right hand side. It's 2 to the power x plus 4 and 2 to the power x. They are separated by a plus sign. These are two terms. So what we can do is we can split. Okay, what we notice is that this is a 2. This is a prime number, it's a prime base. This is also a 2, it's a prime number. This is also a 2, it's a prime number, it's a prime base. There's an exponent, it's plus 4. There's no plus anything there, all right? And then there's a constant term on the right hand side. So it's very clear then that from this exponential equation, to answer this exponential equation, you also can see that the variable x, the exponent, has a coefficient of 1, whereas this variable exponent has a coefficient of 1 as well. So that means that the variables are the same, all right? So that it means then that we can split this fraction into 2 to the power x and 2 to the power 4, and then this can be 2 to the power x alone. Then take out the common factor and solve from there. Okay, so these are things that we know we ought to do with that particular question. Moving right along to this one. This is an inequality question. And for our inequalities, let's not forget the procedure that we need to follow when answering an inequality question. Okay, we have a product of factors here, x minus 8 and x plus 2. It's less than or equal to 0. So we need to understand what less than or equal to 0 means. And we need to check the product of that we have, x minus 8 plus 2. We can write our critical values, right? And from represent representation, and then after that, we can then get the solution of this particular inequality. 1.1.5 here is a typical what? Third equation. Guys, with the third equation, we need to remember that the step that we need to first follow, there's a procedure of writing the equation first in standard form, in that you isolate the third, and when you've isolated the third is isolated, you can then do what? You can square both sides of the equation. Then after that, you make sure that you get the equation in standard form, you factorize, you get your solutions of x, and then after that, you do what? You write down your solutions. After writing down your solutions, you must check. Third equation means you check your solution. You always check your solution in a third equation. (1.2) A rectangle having sides y minus 3 meters and x plus 2 meters has a perimeter of 24 meters. Guys, when we read this statement, hopefully we understand that our dimensions of this rectangle, you have one dimension in terms of y, you have the other dimension in terms of x. And then we are told that the perimeter is 24 meters of this particular rectangle. The what? The perimeter. What is perimeter, guys? Perimeter, what is it? What is this? What is perimeter? Do we know what perimeter is? Do we know what perimeter is? Do we know what perimeter is? Perimeter is the peri means outside. Meter implies distance. So perimeter means outside distance. So this is the total distance around a rectangle. Do we know what the perimeter of a rectangle actually is? Guys, the perimeter of a rectangle, okay, is actually equal to 2 lengths, because there are 2 lengths that you have there for your rectangle, plus 2 breadths. because you have two breadths in your rectangle. So if you add these two together, you should get the total distance around this rectangle. So that is the perimeter formula for a rectangle. It's two lengths plus two breadths. And then from there, okay, we want to check the other concept that is there, which is what? And the area of 32 square meters is given for the rectangle. A what? An area. What is an area, guys? Area is the inside of the rectangle, measured in square units. Okay, the inside space of a rectangle is what we call of a rectangle times the breadth. Okay, because when you multiply the length and the breadth, you will get your accompanying square meters. Okay, your accompanying square meters will come when you multiply the length and the breadth. Now what they are asking now is calculate the values of x and y given this information. So let us see how we set up the situation. We are told that the one of the sides is y minus 3. Then the other length is x plus 2. So the opposite sides of a rectangle are equal. So we are told that the perimeter is equal to what? 24 meters. So that means that if we are to calculate the perimeter is 2 lengths plus 2 what? 2 breadths will be equal to 24 meters. So in the place of the length, let's just substitute. It doesn't really matter. 1 minus 3. In the place of the breadth, let's substitute x plus 2, which will be 24. We set up the equation. 2 times y is 2y, 2 times negative 3 is negative 6. Plus 2 times x, which is 2x, 2 times 2, which is 4. That is equal to 24. So in terms of x and y, 2y plus 2x is equal to 24 minus 4 plus 6. You transpose the 4, it becomes negative 4. You transpose the negative 6, it becomes positive 6. So what do you get? 24 minus 4 is 20. 20 plus 6 is 26. So 2y plus 2x is equal to 6. This will be my first equation. So I use my concept of perimeter to set up an equation because I've been told that the dimensions of the rectangle are y minus 3 and x plus 2 respectively. So then I use that, I get my first equation. Remember, I was told that the area of the rectangle is equal to what? 32 square meters. So let's use the area of the rectangle. Yes, thank you, Lungan. Area is definitely the inside of the rectangle measured in square meters. K, you have a question mark. What's happening? You have many question marks that you've written there on the comment section. I don't understand why you have many question marks. What are the question marks for? Okay, we're answering this question. Okay. The question says, the area of a rectangle having sides of y minus 3 meters. Here's the y minus 3. And x plus 2 meters. There's the x plus 2. Has a perimeter. What is perimeter? Perimeter is total distance around the rectangle. It has a perimeter of what? Of 24 meters. Okay, so let's just stop here. What is the perimeter of a rectangle? The perimeter of a rectangle is the total distance around this rectangle. So in other words, it would be like saying this breadth plus this breadth, which is 2 breadth, plus this length plus this length, which is 2 lengths. The addition or the summation of that gives us the perimeter of the rectangle. Okay, so I can set up then my first equation using perimeter. The perimeter is equal to 24 meters, but I know that the perimeter of a rectangle is 2 lengths plus 2 breadths, which is 24 meters. Then after that, what can I do? In the place of L, I'm going to substitute my length, which is y minus 3. There it is. I substituted using brackets. In the place of B, I substitute x plus 2. Here is x plus 2. I use it, substitute using brackets. It is equal to 24. There's the 24 there. So then I say 2 times y, which is 2y, and 2 times minus 3, which is negative 6, plus 2 times x, which is 2x, 2 times 2, which is 4. There it is equal to 24. There it is. Then I add my like terms and transpose the constant terms. So 2y plus 2x I can bring together. The minus 4 plus 6 I can transpose. The negative 4 becomes positive 6. The positive 4 becomes negative 4. I add the like terms, I get 26. So 2y plus 2x is equal to 6. That's my first equation. Using what? Using perimeter, I get equation number 1. Now for area, using the area formula for a rectangle, I can now set up a second equation. What is area? Area is length times breadth. Area of any shape is the lungan. Area is the inside of a rectangle and it's measured in square meters. So in actual fact, area is the inside of any two-dimensional shape and it's measured in square meters. So I'm told that the area, according to the question, says the area, the perimeter is 24 meters, but the area of the rectangle is 32 square meters. So I'm going to say area is equal to 32. Then the length times the breadth will give me 32. This is for the rectangle. So in the place of L, I substitute the length, which is y minus 3. And in the place of breadth, I substitute x plus 2 in brackets, which is equal to 32. Then what do? I distribute the first term into the two brackets. Y times x is xy. Y times 2 is 2y. Negative 3 times x is negative 3x. And then negative 3 times positive 2. Negative times a positive is a negative. 3 times 2 is 6. Okay, then it's very clear that I have xy plus 2y minus 3x is equal to 32 plus 6. I transpose the negative 6, it becomes positive 6. I get xy plus 2y minus 3x, and that is my equation 2. So in this question, guys, where you would typically have a simultaneous equation given to you, where you have one equation and another equation and they say solve for x and y, they have given you a word problem to find the values of x and y for a rectangle having sides y minus 3 meters and x plus 2 meters, and which has a perimeter of 24 meters and an area of 32 square meters. So I use this information to set up two equations, as you have seen me do here. With the perimeter, I got this equation. With the area, I have this equation. Now I have two equations that I can go ahead and do what? And solve simultaneously. Right? So I'm going to take this first equation, try and isolate one of my variables. Two y plus 2x is equal to 26. If I take the y, make it the subject, it means 2y gets isolated, 2x gets transposed as 26 minus 2x. Then since I want y alone, I divide both sides by the coefficient of y. The coefficient of y, or the number next to y here, is 2, which is multiplied to y, the coefficient. So I'll divide by 2. Y is equal to 13 minus x. This is going to be my equation 3. So equation 2 now becomes equation 3. Then I take equation 3. I substitute equation 3 into the other equation that has not been touched, which is equation what? Equation 2. Take equation 1, the substance of equation 1, which is 13 minus x, in the place of y. So in the place of y, I substitute 13 minus x in equation 2. So let's go and substitute that. So 13 minus x is to be substituted everywhere where y appears in the equation. So let's go. xy plus 2y minus 3x is equal to 38. 13 minus x. Remember, 13 minus x, y is equal to 13 minus x. So in the place of y, in brackets, I substitute 13 minus x. Okay? Hopefully so far we are together. If anyone is lost, please let me know in the comment section. If there's something that you don't understand, let me know. Then I can distribute x times 13 minus x. Okay, let's distribute that. 13 times x is 13x. X times negative x is negative x squared. 2 times 13 is 26. 2 times negative x is negative 2x. Minus 3x is equal to 8. I wrote 8 instead of 38. Oh, thank you. Thank you. You're a rock star, K. Okay. And K, isn't this the very things that we usually do when doing step by step? So please, K, learn something from me, my mistake. Make sure that when you write, you make it a point that you do not leave out, numbers or something. Okay. It is not the first time I'm doing something like this. I had done something like that when I was writing this equation. I actually wrote on the other side. When I took 2x, I transposed it. I wrote x, and I forgot to put the 2 there. Okay, and that's carelessness from my side. So please, guys, make sure that you nurture the thing of not being careless, and you end up dropping numbers or dropping letters or dropping exponents unnecessarily. That's sabotaging yourself for the answer. So thank you so much, Kay. Really appreciate it. You're the best. Negative x squared, I take the like times 13x minus 2x minus 3x. I can add these. 13x minus 2x minus 3x. That's 13x minus 5x. That's actually what? 8. Then 26. I transpose the 38. So 26 minus 38. Okay, should give me what? It's 12, right? Negative 12. So I have negative x squared plus 8x minus 12 is equal to 0. Then, since the coefficient is negative, I divide all the terms by what? By negative x. By negative 1. So that becomes negative 8x. That becomes positive 12. That becomes 0. Sure. Then the factors. Okay, if the sign is positive and my middle term is a coefficient that is negative, and I know that I look for my factors of 12. Hi, Junior. How can this be physics? Hi, Junior. Hi. Then remember, positive means same signs. So the same signs according to the sign of the middle term. So that means now I need to check the factors that will actually add up and give me negative 8. So negative 12 and minus 1 won't give me negative 8. Negative 6 minus 2 will give me negative 8. So I know it's negative 6 and negative 2. That's fine, Junior. I'm happy. If you use the quadratic formula, that's great. Okay, that's fine. So x is equal to, remember that x minus 6 is equal to 0, or x minus 2 is equal to 0, right? Because the product of zeros will give us 0. So if we can say this bracket is equal to 0 and that bracket is equal to 0, that means I'm on my way to finding the actual x values. Okay, so x is equal to 6, or x is equal to what? To 2. We are not done there. Then you go and you substitute. In your equation 3, which is 13 minus x, you go to that equation 3, you go and substitute x so that you can find the y values. So now we are going to go and substitute x is equal to 6 or x is equal to 2 where? Into equation 3, which is this one. So I go and substitute the 6. And I go and substitute the 4. So I get these values. Y is equal to 7. Y is equal to 11. You see? Hi guys, hi. This is nice. It's so nice. It's so nice and straightforward. Okay? You're welcome, Kay. Thank you for the question as well. Thank you for the question. Thank you for your contribution. Really helpful. Okay, so this was from the DBE May-June 2025 paper, guys. Okay, and the simultaneous equations, though you may be used to simultaneous equations being given, where you are given the equations themselves, sometimes you get a word problem, and then you have to actually read the word problem, apply your mathematical knowledge of understanding rectangles, perimeter, area. These are things that you need to know as a grade 12 learner and as a grade 11 learner, because remember, this preparation here or this revision is relevant for grade 12 learners and grade 11 learners, because grade 11 and grade 12, for question 1, you guys pretty much are doing the same thing as those learners. Let's look at this question. Question 1.3, guys, sometimes is a question that many learners, it depends from year to year. I would actually invite you as a grade 12 learner to go through all the question papers that have ever been there for final end of year. So you go and check out 2014 end of year November, 2015, 2016, 2017, because remember CAPS started in 2014, 2015, 2016, 2017. You have basically 10-year papers to look at from 2014 up until 2024. You have 10 question papers that were written end of the year that you can look at. And what you can do, guys, you can go and check the pattern. This seems to be a common pattern. They start you off with a basic solve for x, where you can either factorize or, guys, use the quadratic formula if factorization is a problem. 2, where you have to use the quadratic formula because you have to round off to 2 decimal places. Please take note, sometimes if they say round off to correct to 2 decimal places, if they say correct to 1 decimal place, you must know how to round off. If they say leave your answer in simplest surd form, then you must be able to leave your answer in simplest surd form. 1.1.3, sometimes it's an exponential equation. It can be, all right, but just go and look at the pattern of other papers written in previous years, 2014, 2015, 2016, 2017. Go and look at the trend. Okay, there's a trend that you see, all right, and it helps calm you when you are a person who's preparing for the maths exam next week, Friday. Okay, 7 days from now, guys. So you have all the time in the world to prepare so well and get your level 7, that is 95 and above %. You have all the time in the world. So anyways, look at your exponential equations. Sometimes the exponential equations are these type, where you have to take out a common fact. Sometimes the exponential equations are the type where you have to use the K method, the quadratic trinomial. That is a exponential what? Exponential equation. Use the K method, you substitute the K values back to what you let, and then you solve for x. Or it can be those exponential equations you did in grade 8 and in grade 9, where you have a variable, where you have a base on either side of the equal sign, and you have to simplify from there. Okay, so that is very important. Tabi saying, what grade are you in? It's better if you're in grade 11, my leader, because if you're gonna say you're in grade 12 and you need a tutor, because maths is showing you flames, that's like literally 7 days to kind of help prepare you for that paper. And then 1.1.4, guys, inequalities. Okay, we need to know the procedure that is attached to inequalities. All right, the what? The mathematical procedure. Okay, the mathematical procedure. Hopefully we know that for inequalities, I'm just going to look at this question very quickly. By now, the procedure should be straightforward, guys. What's beautiful here is that this question is already in standard form. I mean, it's already in the factor stage. Because usually we check standard form, then we factorize, then we use the zero factor law to find the critical values. Then we must draw a graph to represent the critical values, and then the answer should then follow. So these are the steps that we follow when we are answering a inequality question that is quadratic in nature, like this one. So we are already in the factor stage. We are here. We have passed standard form. We are now here already. So all we need to do is we need to continue from this point. Always check your question. Where are you at? What stage? Okay. Exponential question was 2 to the power x plus 4 plus 2 to the power x is equal to 8,704. Oh, I see Intabi saying. So you're writing in June, you are writing something like this, then this was the paper written in June by those who are upgrading. Okay, this is the paper that I'm looking at, the paper for the upgraders. Those papers tend to be really meaty, they have a lot, So Ntabi saying, you must contact me on the side, after this live session, just send me a message and we can see how I can help you. I can help you even during the festive season. Yeah, and then I can help you there. So, right. So that was the exponential equation. So the inequality, that's the procedure. Standard form, we've passed. Factor stage, we are there. Zero factor law. Well, if we are saying now we are getting the critical values, we apply the zero factor law. We know x minus 8 is equal to 0. And x plus 2 will be equal to 0. So our x values for our critical values will be x is equal to 8 because 8 minus 8 will give us 0 there. Or x is equal to negative 2 because negative 2 plus 2 gives us 0 for that bracket. So those are the critical values. Critical value, done. Graphical representation. This is the x-axis, your number line. Negative 2, your smallest critical value. 8, your biggest critical value. Right? Then you interpret this thing here. The product of factors gives you something less than 0. What does less than 0 mean? It means below the x-axis. Guys, this is the x-axis, and below the x-axis, this is basically what you have below the x-axis. So from which x value to which x value do you have this? It's from negative 2 to 8. So what you can do, you can write your answer in one of two ways. You can either say, less than means below the x-axis. Less than 0 means below the x-axis. Equal to 0 means on the x-axis. So we want the interval that shows us the function being below the x-axis and on the x-axis. So it's on the x-axis at negative 2 and 8. And it's below the x-axis between negative 2 and 8. So you open both inequality signs, their mouth, they open. I usually say this is Pac-Man, guys. Pac-Man, remember Pac-Man? So the mouth is open to this side. The inequality signs all open towards the right. Then you write your smallest critical value or biggest critical value. And then since you are looking for less than 0, that is your answer that shows less than 0, between negative 2 and 8. If you are looking for on the x-axis, it means you say equal as well. This is your answer. This is 2 marks that you get for writing the answer. If you don't write down this answer, you miss these 2 marks. Or you could write your answer in the interval notation form. This less than and equal means square bracket. Okay? Less than and equal means square bracket. Less than means open bracket. This means the answer is included. Included. This means the answer not included. So the reason why we include negative 2 and 8 is because we were told that less than or equal, the equal part means on the x-axis. It's on the axis on the critical values. So it must be equal to the critical values as well. It can't just be x is greater than negative 2 but less than 8. It must be less than or equal to negative 2 but less than or equal to 8. Okay? So then you can say from negative 2 to 8. This is another way of writing the answer. So you choose. Do you want to write your answer in inequality form or do you want to write your answer in interval notation? If you write your answer in this way, you will get all your marks. I just joined and I struggle with inequalities. Okay. So I am just answering this question, Mihle. And the question says x minus 8 into x plus 2 less than or equal to 0. Okay? So what I'm saying to you guys is the following. X minus 8 into x plus 2 less than or equal to 0. There's a procedure when you answer inequality questions. The procedure is you must first get your equation into standard form. Now what is standard form? Standard form is simply this form, ax squared plus bx plus c, either less than 0 or greater than or equal to 0. But this is the form, all right? This is the form. And this is what we mean by standard form, where a is positive. Okay? 2, we must then factorize. In other words, we must get the factors after the standard form. So for instance here, this question is already in this stage. It's in the factor stage. X minus 8 into x plus 2 less than or equal to 0. Step number 3, you apply the 0. There's a 0 here. Factor, there are factors there, x minus 8 and x plus 2. Law. The zero factor law says when you have a product of factors and there's a 0 on the other side, you take this bracket equal to 0. Take that bracket equal to 0. Then you get the solutions. So what makes this bracket be 0? It's when x is equal to 8, because 8 minus 8 is 0. What makes this bracket be 0? It's when x is negative 2, because negative 2 plus 2 is what? Is 0. Okay. So hopefully so far we are together. This is how you get your critical values. You must write CV next to the values so that the person who's marking you knows that you are identifying the critical values. Okay? Yeah. And there are 2 of these critical values and they are different. They are not the same. This is your smallest critical value. So on your number line, because number 4, you must draw on a graph that particular critical value. Okay? So I will do 1.1.3 no buhle, don't worry. So then, this is the critical value negative 2. That's the critical value positive 8. Okay? Then what do we do, guys? What do we do now that we are here at this stage? What we then do is we draw the graph through the critical values, and then we come here and we interpret what does the inequality mean at that factor stage. What does this inequality mean? What does less than 0 mean? Guys, less than 0 always means below the x-axis. Ngaphansi kwe-x-axis. Honor the x-axis. Underneath the x-axis. Not on top of the x-axis or above the x, but it means underneath. Less than 0 means below the x-axis, underneath the x-axis. So we come here to the graph and we check, where is the function underneath the x-axis? It is there in between. So I usually like shading this part personally to indicate that there is my answer. But from where to where is my answer for this shaded region? It's from negative 2 to 8. Okay? That is less than 0. But then, additionally, we must check for equal to 0. What does that mean? It means on the x-axis where the critical values are. So it means on negative 2 and on positive 8. So then we write x in between, because this answer lies between. We write x in the middle. We write the inequality signs, both of them opening their mouth to the right. Please, guys, not opening their mouths to the right, both of them. -2, your smallest critical value on the left. Your smallest, guys, must be always on the left, not your biggest. Then on the right, your biggest critical value. And you write the inequality sign, equal, less than equal, less than equal. So what does this mean? It means when x is greater than or equal to -2, this is the region where x is greater than or equal to -2. Greater than -2, equal to -2. And x is less than or equal to 8. This is the region where x is less than or equal to 8. Less than 8, equal to 8. So that's how we write the answer. Or we can write the answer in interval notation. We know that square brackets means less than equal or greater than equal is for square brackets. That means the critical value is included in your answer. Use square brackets for inclusion. You use open brackets to show that that value of the critical value is not included. So that's why here we say x is an element, square brackets, from -2 to what? To 8, square brackets on either side. And that closes the chapter for our answer. That's how we do when we have less than or equal to 0. Or if we have, let's say the question was different and it said x minus 8 into x plus 2, less than 0 alone, no equal sign, then it would still be critical value is equal to 8 and -2. We would draw the graphical representation of the answer, -2 small, 8 big. What does less than mean? It means below the x-axis. So that means our answer lies below the x-axis. But in which interval? Between -2 and 8. So I can say x is an element if I want -2 to 8. Why? Open brackets. Why am I using open brackets this time around? Remember, I said when there's no equal sign, it means the values of the critical value are not what? Included. So we use open brackets for that. Or you could say in between, you write the x, you open your mouth of the inequality onto the right, you write -2 and 8 like that, no equal sign, because in your inequality sign there's no what? Equal sign. Okay? And please replace the inequality sign with inequality sign. Millicent, I have no idea what you're talking about. I'm actually quite lost. What are you saying? Okay. Mihle, just one more thing. Yeah, I've just extended an invite to Millicent because I don't understand what you mean. Just Mihle, here's one other thing. Let's say that the sign of the inequality was not less than, but it was greater than. How would we go about it? Just wait, I'm just going to answer. Millicent, what's up? You said replace what?
You see where you've written the critical value.
Yeah.
There's x is equals to 8, or you
X
should
is equal to -2.
Yeah, please replace those equal signs with inequalities, because some tend to make the mistakes that you did.
What mistake did I do?
The one equal sign. It shouldn't be an equal sign. It should be an inequality sign instead of an equal sign. I don't know if you understand.
I need to understand you better. So, as I said to you, when you are answering a question on critical value, on inequalities, the equation must first be written in standard form. Then you need to get your factors. Then you get your critical values. What are critical values? Do you know what a critical value is?
I do understand and I know critical values. Hence, I'm saying please replace that equal sign. Check a lip.
This one. This one.
Yes, it shouldn't be an equal
Replace it with
sign. Let me
what?
show you are dealing with the inequalities. So it should be inequality signs, not the Ew, okay. Nah, it's fine.
Millicent, unfortunately, I'm just going to have to say that I think you do have a bit of a misconception, right? The,
Okay.
the thing is, the reason why I write critical values at this stage, the reason why I write critical values at this stage is because a critical value is
Mm-hmm.
a root of an equation. That's what a
Okay.
critical value is. A critical value is a root of an equation. In other words, it is your solutions of a normal equation when you are solving for x. That's what a critical value is. We also call a critical value your x-intercept. Those are the two things that are actually we mean by when we say critical value. So I deliberately write equal here because I am saying to the learner, you must, before you write your answer at the end, write down your critical value so that you can indicate those roots, those x-intercepts on your graph. -2, which is a root or a critical value or a x-intercept. 8, which is a root or a x-intercept. All right. So that's why basically there's no inequality sign. We cannot at this stage write CV, which means critical value, and then write an inequality sign here. It's a misconception and it leads to errors. You will not get marks for writing a inequality sign where
Oh,
you are supposed to write critical value. You
okay.
lose marks here in actual fact if you do that.
All right. Now it makes sense because I usually wrote maybe after that the first equation I used to write x is greater than or less than, instead of writing the CV x is equals to 8 or x is equals to -2. So now I get the point why you've written
Yeah.
x is equals to 8 or x is equals to -2. Thank you so much.
Powerful. No, I'm glad then. So hence I speak about the procedure that we follow. Hence I actually highlighted the steps here of answering a critical, an inequality question. That it's important to write your equation that you have, if it's quadratic in nature, of course, then your equation should be in standard form. Then you should follow it up with writing the factors. Then you use your zero factor law to write down your critical values. As young Mecca said, that zero factor law, you are saying x minus 8 is equal to 0 or x plus 2 is equal to 0. That's you on your way to getting your critical values. Once you have them, you go and represent your critical values on a graph so that we can then be able to read from the graph what our answer is for the inequality. Then when you've represented your critical values on your graph, then you can then interpret what this symbol means. Less than or equal to 0 for the graph means that this function is less than 0. In other words, it's below the x-axis. Where is your function below the x-axis? It's between -2 and 8. Hence, I shade this region to indicate that from -2 to 8,
Oh,
that's where my answer is. Then if I
okay.
look at the equal sign, it means on the x-axis. Where are we on the x-axis? We are on the x-axis exactly where my critical value are. -2 and 8 indicate equal on the x-axis. So then when I write my answer, I'm going to say my answer for below the x-axis lies between -2 and who? And 8. So then that's why I said to you guys, you can write your answer in inequality form and say your x is going to be greater than or equal to -2. In other words, the values are this side of -2 and less than or equal to 8. Less than or equal to 8 means here in this space. So we are lying here in between. So x is between -2 and what? And 8. Or you can write your answer in inequality form, and I mean in interval notation, and say x is an element from -2 to 8 using square brackets. Why are we using square brackets? It's because when you have a less than or equal or greater than or equal, That means you include the critical value. So you can use a square bracket to then write your answer in interval. This means the same thing.
Okay, thank you so much then. Now I
You are so
understand.
welcome. You are so welcome,
Thank you.
Millicent. And it's so important if you guys are going to be writing next week that I am, and what I'm saying to you guys is that for inequalities, you should be getting those marks, hands down. Those are your marks to get. Question one is your marks to get, you know? Yeah, so we shouldn't be making silly errors or mistakes. You should spend less than 3 minutes answering this 3 mark question because it's 3 marks. You should spend less than 3 minutes, get it over and done with, move on to the next thing, move on to the next thing so that you can get through the paper and write within the time period of 3 hours. Okay? All right. Okay. Thank you as well for asking or saying something in the comment section. I prefer that from someone than anything else. Guys, I really love it when someone, because you see, if Millicent didn't ask that question, I promise you, or if Millicent was not confident to just type what she knows, because guys, please, I am here not only just obviously to help answer these questions, but I'm also here to sort of like remove the cobwebs that are in your mind to clarify the misunderstandings, the misconceptions you might have when it comes to these questions. Because the more clear you are, then the more confident you will be. If you are not clear, guys, you will lack confidence when you step into an exam, a question paper, and you have to write it. So I hope that's clear. I wanted to then sort of like step into this world for Uluyanda, okay? Because these questions, both of them, had less than, and also this one had less than. So in both situations, we're looking at below the x-axis. Because less than 0 means below the x-axis. When we had the equal sign, we obviously included the critical values. When we did not have the equal sign, we did not include the critical values. Now, I want to check now. Had the question been asked whether the inequality sign is greater than 0, how would we have navigated answering that particular question? So this is x minus 8 into x plus 2. So if we look at the stages, we are at the factor. So we move on to the critical value. CV, x equal. What would make this bracket 0 if x is equal to 8? Or x, what would make this bracket be 0? -2. Okay? Okay, so we are here now. These are our critical values. Next step after writing down the critical values, graphical representation. A to the side. Then after that, what do? We come and interpret what this means. Now let me just write greater than or equal to so that we can appreciate what we are supposed to do. For greater than or equal to, and then I'll do greater than 0 alone as well so that we can appreciate what happens there. What does greater than mean? It means above the what? The x-axis. Maybe some of you are like saying, why is it above this time round? Guys, anything that is greater than 0 when it comes to our Cartesian plane, when we talk about this, we are saying y is greater than 0. Where is y greater than 0? Guys, y is greater than 0 here. Above which axis? The x-axis. So that's why when I say greater than 0, we mean above the x-axis this time now, not below, not underneath, above, on top of the x-axis. Then equal to 0 means on the x-axis. Okay, now, what do I do now that I'm here? I say simply, guys, I just say greater than or equal to 0. That means above the x-axis, it's in this region. Above the x-axis, it's in that region. That's above the x-axis. The minute from -2 we go in that direction, the function is above the x-axis. You can see it will infinitely go and appear on the x-axis. From this critical value onwards, the function starts being above the x-axis. So this side means when x is less. Who is x? X are all the values that are this side. These values that are this side of the -2, this critical value, are less than -2. Are we together there? All of the values this side are less than -2. Or we can say from 8 onwards, all these values this side are what? Are greater than 8. So that means above the x-axis been taken care of. The equal sign, what about on? It means where the critical values are, we include them. Where the critical values are, we include them. This would be your answer. X is always smaller than your smallest critical value, and x is always bigger than your biggest critical value. This is how you write your answer for above the x-axis when there are two critical values. I'm going to stop right here and ask, do we all understand what I've just explained? Do we get it? Luyanda especially. I would be hoping that Luyanda, for instance, who was asking, with the whole inequalities, hopefully you get it now, all right? And then, never mind that alone, let's say that there was no greater than or equal to, it was just greater than alone. If it was just greater than alone, then what would happen? What would happen, guys? CV. Graphical representation. Answer. X is above. Above. We are looking above alone, not equal. There's no equal, so we're not looking on the x. We're just looking at where the function is above. It's above where x is less than -2 or where x is greater than 8. That's it. Done. Finished. Clear. No equal sign. Okay? Those who are people that like writing things in interval notation, this is what you would write. X is less than or equal to -2 is the same thing as saying from -infinity to -2, square bracket, or from 8 to what? To positive infinity, open bracket. Listen. You could do it like this. Say x is an element and then write. Okay. Now, sometimes some people like using the or can be written as the union, Or means union, Like in probability, you usually use this symbol, okay? Select, I've just explained less than 0, my dear. Select apala fala. I just explained less than 0. What happens if it was less than 0? If it was less than 0, we said less than 0. What does less than 0 mean? It means below the x-axis. If there are two critical values, and we have less than 0. Less than 0 means below the x-axis. Then the equal to 0 means on the x-axis. So below the x-axis is here, in between. You see? So that means from -2 to 8. Okay? Yeah. So that's how you would write your answer. X is in between. Your inequality signs all open their mouth to the right, and it's from -2 to 8. And obviously, since there's also on the x-axis, it means you include the critical values as well. You could write the answer in inequality form, or you could write the answer in interval notation. Okay? In this way, where there's equal sign, then look at this, from -2, okay? Yeah, that means there's no equal sign this time around. And obviously, there's no equal sign, it means we are not going to include the critical values. It's still in between the critical values, but we don't include the what? The critical values. Okay? So in interval notation, we can use open brackets, not square brackets like we did when there's an equal sign, but we can use open brackets. So you can either in this way if you want, or that way. You don't have to write both, but choose one way of writing the answer and as such. Okay? The Eastern Cape paper, guys, Those who are Eastern Cape learners will know that we're given, all right, so I'm not going to write the same question, but Eastern Cape learners in the trial exam were given a question where for critical values, there was only one critical value. What do we do when there's one critical value? X minus 2 into x minus 2. That means our critical value is going to be x is equal to 2. Because if you substitute 2 here, 2 minus 2 gives you 0. For this bracket as well, 2 minus 2 gives you 0. So there's only one critical value here. 1, not 2. So what do we do when it comes to graphical representation if there's one critical value? Well, you draw a graph that touches on the x-axis, because it means we only have one critical value, means one x-intercept, not 2. One critical value means only one x-intercept, not 2. Then you come and interpret what that means. Now, I want to look at this situation under all the circumstances that are possible. Let's look at when they say greater than 0. What would we have said? Greater than 0 still means above the x-axis. So when we write the answer for above the x-axis, okay, so I know there's not enough space there. Let me just, and that's actually very untidy, so let's just try and get a bit more space. Let me repeat. There it is again. Okay. I want to look at all these scenarios so that still, I think we are all clear that, you see. Okay, let's look at these two first. So what does greater than 0 mean? Just means above the x-axis. So what am I looking at? Where is the function above the x-axis? It's above here. It's above there. But on the x-axis, it's not above. So I'm going to say x is less than 2 or x is greater than 2. You could write your answer this way. X is less than 2 or x is greater than 2. That's where the function is above the x-axis. Or someone else could say x is an element of real numbers, but x cannot be 2. In other words, x can be any real number from left to right, but there's only one exception. Because we are looking at above the x-axis and not on the x-axis, it means I'm just going to exclude the value of 2. So these are two ways of writing this answer if you want. Or maybe in interval notation, someone else will say from negative infinity to 2, or from 2 to positive infinity. Okay, so I just want to appeal to you that there's these ones, when you have one critical value, and you must also know the approach to follow when there's one critical value. Okay, I hope you guys understand. More importantly, I hope you guys understand this whole thing, this whole idea of greater than 0 means above the x-axis. Where are we above the x-axis? We're above the x-axis everywhere except this critical value, which is 2. So I can say x is less than 2 or x is greater than 2. I could write the answer in this way. I'll get 4 marks. Okay, let's come here. What does greater than or equal to 0 mean? Greater than means above the x-axis. Equal means on the x-axis. So where are we on the x-axis? At 2. Where we're above the x-axis? Everywhere from left to right. So here I can just say x is an element of real numbers. Every value of x will satisfy this inequality. Every value. So I love saying this element of R means everywhere. 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 Every value. Like this ER looks like, it's like it kind of like looks like a short form for everywhere, you know? So every value of x. Okay, let's look at the same question and look at less than 0 and less than or equal to 0, so that we are now clear. And I will leave you guys shortly because I have to go and do other things here. Critical values, x is equal to 2. Of course, one critical value, there's 2 there. Less than 0 means below the x-axis. So this means below the x-axis. So my question then is to you, do I see a function, do I see the function below the x-axis? Is the function represented anywhere below this x-axis? I need you guys to answer me in the comment section. Do I see the function in the below, being below the x-axis anywhere? Yes or no? Don't tell me I'm speaking to ghosts here. Is the function below the x-axis anywhere? Thank you to me forever. Yeah, I thank you. For a moment I thought I am speaking alone. So yes, no guys, there's nowhere where the function is below the x-axis. So what does that mean? It means x has no solution. No solution for x, guys. Because below the x-axis, the function does not exist below the x-axis. So there's no x value that we can indicate where the function is below the x-axis. One more, x squared less than or equal to 0. CV. Guys, I hope now you are like, I'm sure as you guys are seeing me do this thing so fast, you're like, Suka, now this thing, procedure. It's a matter of just, you need to practice the procedure, be comfortable with the procedure, and then you can say inequalities is sorted and you can move on to the next important, thing that you need to work on as an individual. And that's it. Less than 0 means below the x-axis. Is the function below the x-axis anywhere? No. So there's no answer for below the x-axis. There's a no. What about equal? Equal means on the x-axis. Do we see the function on the x-axis anywhere? And where is that? Tell me in the comment section. Where is the function on the x-axis? Because I saw below the x-axis there's no answer, because the function is not there. But on the x-axis, is the function on the x-axis anywhere? Yes, Hunati, thank you so much. At 2, on 2. Nati, thank you so much. Yes, so x is equal then to what? To 2. That is the answer that you write as your conclusion. Okay. Guys, hey. Yeah. So this is it, guys. This is that. Inequalities can be addressed in that way. Okay. Someone said that they want me to do 1.1.3. So let's do 1.1.3. Let's do it in the formal answer sheet, the answer book that is there. 1.1.3 says 2 to the power x. Guys, now I'm just giving you these vibes, because when you're writing the paper, this is what you'll be writing on. 2 to the power x plus 4 plus 2 to the power x is equal to 8,704. So as I said to you, if you look at this equation, this exponential equation, this is 2 to the power x plus 2 to the power x is equal to 4. I will go into 1.3. I thought someone said do 1.1.3. I'll do 1.3. Chill. So what we do is we split. And the reason why we split is because this base 2, which is prime, has an exponent x, which is common to this exponent x. That's why we split. We split and then we take out the common factor, which is 2 to the power x. The base with the unknown variable is the common factor. We are left with 2 to the power 4. And remember, sometimes learners mess this up. 2 to the power x times what gives you 2 to the power x? Please, guys, I've seen learners many times not write this plus 1. They'll write 2 to the power 4 alone in the brackets, and they will forget that there are two terms. When you take out the common factor 2 to the power x, on the left you are left with 2 to the power 4. There it is. On the right, It's 2 to the power x times what gives you 2 to the power x? It's 1 that you multiply. Please, 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 my people. Then 2 to the power 4 is 16. 16 plus 1 is 17. This 17 is a coefficient, so we divide by the 17 both sides. I need someone to tell me, what do you get when you say 8,704 divided by 17? What is the value that you get? Come on, comment section. You guys are here, right? What's 8,704 divided by 17? Come on, come on, come on, come on. Come on, come on, come on. Thank you. Spelelete. You are the one, Spelel. You are the one. Spelel, I've been searching for you everywhere. I think I've found my soulmate, my math soulmate. 512. 512? If you write 512, 512 is equal to shift fact. Can you write 512 so that it has a base 2 as well? That's the question. Okay. Thank you. 2 to the power 9. Or someone else could go ahead and use log, which is fine because you guys have done log as well. So x would be equal to log 512. Someone else could basically do it this way, which is perfectly fine. Someone else would say log base 2 512. You will get the same answer. X will be equal. Now, when you have bases that are same, what do? We drop the base, we equate the exponent. X is equal to 9. That is the answer. Or, if you want to use log form, you know x, which is the variable, will be equal to log of 512 base 2. You put this in your calculator, you should also get x is equal to what? To 9. That's also fine. Either way is fine. Okay. Okay, so now someone has said in the comment section, I say when you come back, can you please re-explain 1.2? Here's 1.2 Lungani. Hopefully after this you'll be fixed, like your name suggests, you will be Lunganid. A rectangle having sides of y minus 3 meters and x plus 2 meters. So do we know what a rectangle is? Hopefully we do. Here is an example. Rectangle has a long side and a short side. We call the long side the length. We call the short side the breadth or the width of the rectangle. So we are told that the rectangle having sides of y minus 3 meters and x plus 2 meters has a perimeter. What is perimeter? This is a concept that we covered in grade 9, grade 8, grade 10, grade 11. What is perimeter? Perimeter is simply, the word itself tells you, peri means, it's a prefix that means outside. Meter means distance. So perimeter means outside. The outside distance of this rectangle. That's what we call the perimeter. The total distance, the summation of the distance. Y minus 3, I run plus x plus 2, I run plus y minus 3. I come back to where I started. That is the perimeter, the total distance around a shape. So we are told here that the perimeter is what? 24 meters. So I know that the P, my perimeter is 24 meters. But what is the formula for perimeter for a rectangle? How many lengths? 2 of them. 2 lengths. How many breadths? 2 of them. 2 breadths. So 2 lengths plus 2 breadths is the formula for perimeter for a rectangle. So I'm saying this is equal to what? 24 meters. Then I'm going to use my length, which is y minus 3, substituted in the place of L in brackets. Then I distribute 2 times y, 2y. 2 times minus 3, negative 6. Plus 2b. What's 2b? 2b, the breadth, x plus 2. In the place of b, I write x plus 2 in brackets. 2 times x plus 2, 2 times x, 2x. 2 times 2, 4. Equal to what? 24. There's the 24. Then I basically simplify my equation. 2y plus 2x on the left. Negative 6 plus 4, I transpose, I get 26. So I have a first equation here, which is 2y plus 2x is equal to 26. That's equation 1. Okay? Because simultaneous equations is not there, they give me a word problem. I have to actually now interpret that word problem, write my equations from the problem, and my accuracy in understanding my concept of the rectangle and perimeter helps me a lot. Now I have an equation, that is equation 1. Moving right along, they also said that the area of the rectangle is 32 square meters. What is area of a rectangle? The area of the rectangle is length times breadth. So area is equal to 32 square meters. That's what it is. So I can say length times breadth is equal to 32. In the place of L, I substitute the length, which is y minus 3. So I put it in brackets. L is y minus 3. B, the breadth, which is x plus 2, I put it in brackets, it's x plus 2. Equal to who? 32. Then I simplify this equation. I distribute y times x is xy, y times 2 is 2y, minus 3 times x is minus 3x, and minus 3 times positive 2, negative times the positive is negative 6. Then I simplify xy plus 2y minus 3x, transpose negative 6, becomes positive 6, 32 plus 6 is 38. This is my equation what? Equation 2. Now I am ready to solve two equations simultaneously because the question was saying what? Calculate the values of x and y. So let's go ahead and calculate the values of x and y. This is my 1. This is equation 2. I take my equation 1. I use so me, I'm going to use the substitution method. Okay? Yeah. Which is typically the way in which we solve for x and y. So I'm going to make a subject. What is nice is that all of these are divisible by 2. So I can make it, doesn't matter. I make y the subject, 2y, I transpose the 2 minus 2x, and then I divide by this coefficient of y, which is 2. What I do on the left, I do on the right. I divide 26 by 2, I 2x by I get y is equal to, what's 26 divided by 2? 13. What's negative 2 divided by 2? It's negative x. Okay? That's equal. Now it becomes equation 3. Now I take, here he was, very hunadi. But yeah, you know, that's how they roll when you're writing rewrites. Those people who write rewrite papers in June, who are upgrading, examiners are very dramatic with those papers. Too much, okay? So as these candidates that are writing in November, we need to actually answer this May, June rewrite paper so that we can be confident about that paper as we look forward to our final paper that we'll be writing next week, Friday. And I'm upgrading. Yeah, I will not do that like this. 13 minus x, you take this 13 minus x, you go and substitute y. In the place of y, you substitute 13 minus x in the what? In the equation that is untouched. You see, this equation is the one that you simplified and you got y is equal to 13 minus x. It's the touched equation. Now we must go to the untouched virgin equation. This one, untouched, we take it, we go and substitute our y is 13 minus x there in the place of y. Where y is, we substitute 13 minus x. So I did that. Where y is, 13 minus x in brackets. Where y is, 13 minus x in equation. X times 13 is 13x, x times negative x is negative x squared. 2 times 13 is 26, 2 times negative x is negative 2x, minus that 3x is equal to 38. Now I'm going to add and subtract my like terms. This is quadratic in nature, so I write my x squared term first, follow it with my x terms. 13 minus 2x minus 3x gives me 8x. Then this 26, 38, transpose it, 26 gives me negative 12. My equation is nearly in standard form. My coefficient of x squared is negative, so I divide by the negative 1 for all terms. Negative x squared becomes x squared, that's positive. Positive 8x becomes negative 8x. Negative 12 becomes positive 12. Then I factorize. Or you can use the quadratic formula. I know some people don't really want to waste their time. Use the quadratic formula, or you can factorize. So I did factorize x squared minus 8x plus 12. It gives me x minus 2 into x minus 6. And then 0 factor law. And then my values of x. X is equal to 6 or x is equal to 2. I take these x values, I go where? To equation 3. Equation 3 was manipulated equation 1 was manipulated and made to become equation 3. This here says, I am ready. Y is like, I am waiting. Go and solve for x. I am waiting so that you can get my values. Go and solve for x. I am waiting to get my values. So once we have the x values, we then go and substitute these x values where equation 3. 6 can be substituted in the place of x. 13 minus 6 is 7. Y is 7. 2 can be substituted in the x. 13 minus 2 is 11. Those are my two values. Y as well. X is that. Whereas my y values are that. Okay? And in actual fact, what's beautiful here is that if you think about it, when x is 6, this is actually what we call a point of intersection, where the two equations, they intersect. 2y is 11, the both points of intersection. Simultaneous equations is about finding the points of intersection. So graphically speaking, this is what we mean. But of course, algebraically speaking, you found the value of x at 6, and then the corresponding y is 11. Okay, you guys quiet. Okay, that is that question. Hopefully, the person who was saying too. Now I'm going to just do this last question, and then I'll be leaving you guys in peace. Okay, so that you guys can work on your own stuff. 1.3. This is 1.3. 1.3, guys. Sometimes 1.3. Okay. Usually examiners, they test general understanding of maths from as long as you were able to learn it to now using 1.3. So you must be someone who knows mathematical concepts when you want to answer 1.3, because your 1.3 questions, you can go through 2014, 2015, 2016, all the way to 2024 and check how your 1.3s have been for the past few years. They are never the same. They are never the same. So for instance, this question, we need to understand concepts here. Show that this, which is an expression with exponents, squared minus this, which is an expression with an exponent 2, is divisible by 2 for all real values of m and n. I repeat, show that this and minus that is divisible. Now this is important here. When we say divisible, something is divisible by 2, it means this, guys. It means that particular thing is an even number. Even numbers are numbers by nature that are divisible by 2. Your even numbers. I repeat, even numbers are numbers that are divisible by 2. What are our even numbers? 0, 2, 4, 6, 8, na. Those are what we call even numbers. Okay? Yeah, okay, are we together? So as long as it is 2 times whatever, I repeat, as long as it is 2 times whatever, that means that thing that is 2 times whatever, because guys, let's say that thing that we are talking about is an odd number like 3. 2 times 3, guys, is 6. And 6 is a what? Is an even number. And it's a number that is divisible by what? By 2. Okay, let's say that thing is not an odd number like 3, but it is an even number like 4. What's 2 times 4? 2 times 4 is 8. 8 is also divisible by what? By 2. So as long as we have something that is a product of 2 with something else, then we can clearly say without question that that particular thing is divisible by 2. Okay? Are we together here? Hey, yo. Yeah. 7, on the other hand, is not divisible by 2. Because 6 and 8 are divisible by 2 because when you divide these numbers by 2, they leave no remainder. 7, on the other hand, is not divisible by 2 because 7 divided by 2 is 3. Ne? But you have a remainder of what? Of 1. So that means the number 7 itself is not divisible by 2. So I hope you guys, the concept here is important. Then they are saying, show that this is divisible by 2 for all real values. What does that mean? It means for all real values. Real numbers are numbers, all the numbers that are in the number line. So what they are saying is that for all real values of m and n. So it means if you have m here and n there and n there, doesn't matter what real number I substitute here, at the end of the day, this whole entire thing should still be divisible by 2. Whatever number I substitute there for m and n, any real number that I substitute should ultimately lead to this whole entire thing being what? Being divisible by 4. In other words, when I divide that thing by 2, it should leave no remainder. Hey, I hope I've explained myself well. So what am I going to advise you to do? Grade 12, if you are grade 12. Grade 11, if you are here, just listening because you are here. Grade 13 and 14, those who are writing rewrites, do yourself a favor. Factors, please. Things that are divisible. Okay? Then your number theory. I ask you, you see, look, real values. You see, if you don't know what a real number is, then, real numbers are all the numbers in the number line. Please go and check and make sure you understand what factors are. What does it mean to be divisible? You can do a Meta. If you have WhatsApp, you can go on Meta and you can just have a discussion with Meta AI about factors. And you can ask all the questions that you need. Or if you have ChatGPT, or if you have any other engine that you use that is AI, you can go and discover all the theory around these things. Your number theory, I mean, you need to know what a real number is, what a non-real number is, all these things. For real numbers, please know what a rational number, what is a rational number, what's the difference between a rational number and an irrational number. You need to know what are integers, the symbol for integers, what are whole numbers, what are natural numbers, rational numbers, by the way, the Q, irrational numbers, the Q that has an apostrophe. These are symbols you need to know. You need to know what an integer is, what is a whole number, what is a natural number. Okay? And what is a non-real number? What is a number that is undefined? Hey, guys, hey, yo, all right. Okay, let's go to 1.3 and try and answer this question. Okay, let's write it down. 1 plus x to the power m plus x to the power negative n to the power 2 minus 1 minus x to the power m minus x to the power negative n to the power 2. Okay, now what is interesting here, those who know stuff that they should know, there's one of two ways you could do this. You could open 2 brackets for squared and expand this bracket, distributive law, expand this bracket, distributive law, add and subtract like terms, and then check what you get as your final answer. Okay, so I'm going to do both approaches so that you guys can see. So 1 plus x to the power m plus x to the power negative n. I open a second bracket of 1 plus x to the power m plus x to the power negative n. This is just for my first bracket that is squared. Minus 1 minus x to the power m minus x to the power negative n into 1 minus x to the power m minus x to the power negative n. Okay, right? So step number 1 has been done very successfully. Now I need to distribute. Remember, when you distribute, guys, this 1 needs to be distributed here, first term, distributed to the second term, 1 needs to then be distributed to the last term. What do I get? 1 times 1 is 1. 1 times x to the power m is plus x to the power m. 1 times x to the power negative n is plus x to the power negative n. Then we leave 1, we go to x to the power m, we do the same thing, we distribute x to the power m to all three terms. X to the power m times 1, that's plus x to the power m. X to the power m times x to the power m. Now, laws of exponents are very important. X to the power m times x to the power m. Remember, when we are multiplying same bases for exponents, what do we do when we are multiplying same bases? We add the exponents. So this m and this m, we add them together, we get x to the power 2m. Do you see that? But I don't have to write all of this thing down. I can just hear what I'm saying. Guys, hey, Sonny, guys. Then x to the power m times x to the power negative n. Okay, remember again, bases are the same. We what? This is m plus minus n. M plus minus n, at the end of the day, the positive and negative will give me a negative sign. So I have x to the power m minus n, in other words. So I'm going to say plus x to the power m minus n. Okay, so I'm done distributing this. I got 3 terms. Very good. I done distributing that to these 3 terms. I got another 3 terms. Then the last one is distributing this to the 3 terms again. So x to the power negative n times 1 is plus x to the power negative n. X to the power negative n times x to the power m is plus x to the power negative n plus m. Then x to the power negative n times x to the power negative n. Remember, the bases are the same. We add the exponent. What's negative n minus n? Negative n minus n is negative 2n. Okay. Now, the reality is that we are done with these first 2 brackets. Now we need to move on to these last 2 brackets. And how important it is to be accurate. Because if I'm not accurate, guys, sabotage. Now it seems like I'm not going to have enough space, guys, all right? So 1 times 1, all right? Let me just see if I can't go and rewrite this somewhere else so that you guys can be able to see at the end of the day. You end up not having, remember guys, that in your answer you will see you have additional space at the back, right? Yeah. I'm hoping there is additional space at the back. Yes, you have additional space at the back. You can always come and if immediately in the first step you can see, oh, you expect, please guys, plan before you write. If you can see that you won't have enough space to fit, maybe you need to just make sure that you write very small so that you can fit everything in. Right, so these are things you need to plan for because, unfortunately, you cannot run away from them. So I'm just going to rewrite all of what I've written. x1 plus x to the power m plus x to the power negative n plus x to the power m plus x to the power 2m plus x to the power m minus n plus x to the power negative n plus x to the power negative n plus m plus x to the power negative n. It's a lot, eh? Okay. Now let's move on and go to the other additional bracket. Now remember here, there's a minus sign. So I keep the minus sign. And then I'm going to open brackets and get everything in here with the bracket still there. The negative sign is going to wait on the outside for now. I'm going to FOIL. I'm going to multiply and distribute. 1 times 1 is 1. Negative, positive to negative, negative x to the power n. 1 times negative x to the power negative n, negative x to the power negative n. Remember guys that a positive times a negative gives you a negative term, and then you say x to the power n. Let's move on to this. Negative x to the power times positive 1 gives me negative x to the power m. Negative x to the power m times negative x to the power m, and negative times a negative is a positive. Then x to the power m times x to the power m, I keep the base, I add the exponent, m plus m is 2m. All right? Not done. X to the power m times negative x to the power negative n. A negative times a negative, again, is a positive. And then x to the power m, I add the negative n, so it's plus minus n, which is m minus n. So it's going to be positive x to the power m plus n. We are not yet done. One more term to distribute. Negative x to the power negative n times 1 gives me negative x to the power negative n. Then negative x to the power n times negative x to the power m. Remember, a negative times a negative is a positive. Then x to the power m times x to the power. Oh, wait. What happened here? I first said negative x to the power n times 1 gives me negative x to the power negative n, which is fine. Negative x times negative x to the power m, it is positive. Positive what? Negative n plus m. Positive negative n plus m. Then last but not least, negative x to the power negative n times negative x to the power negative n. So negative times the negative is going to be a positive. The negative n plus minus the negative n gives me negative 2n for my exponent. Now, I think we are ready to distribute. Remember, this negative sign then needs to be distributed to all these terms, because that negative sign, guys, will affect all the terms in this expression. So I'm going to write 1 plus x to the power m plus x to the power negative n plus x to the power m plus x to the power 2m plus x to the power m minus n plus x to the power negative n plus x to the power negative n plus m. Now it's very important here to be very careful as you write. You take the negative sign, you distribute. What's negative times 1? Negative 1. What's negative 1 times, negative times negative x to the power m? It's positive x to the power m. Negative times a negative, positive x to the power negative n. Negative times a negative, positive x to the power m. Negative times a positive, negative x to the power 2m. Negative times a positive, negative x to the power m plus n. Negative times a negative, positive x to the power negative n. Negative times a positive, negative x to the power negative n plus m. And then negative times a positive 2 is negative x to the power negative 2n. Now I'm going to look for what? Like terms. Why? Because you can add and subtract like terms. So for instance, 1. Is there any other constant term? Yes, it's minus 1. 1 minus 1 is going to be 0. Plus x to the power m. Let's see if there's any other bases with the variable just positive 1m, not the ones with positive 2m, because those are different terms. So we're looking for these ones. So x to the power m will be added to this x to the power m. Okay, where's another x to the power m? There, another one. X to the power negative 2n. Where did I forget? Andile. Sorry, you forget to return x to the power negative 2n. Where? Andile 596027999. You said I forgot to write x to the power negative 2n. Now my question, where specifically? You mean at the end? Where? Or the one that you started to expand? The one I started to expand. Okay, let me go back. Thank you so much, Andy. Okay, it's very possible to make these mistakes because, like I said, it needs some lowering. Oh, you're right. What did I write? Negative. And I wrote negative and instead of writing negative 2n. Yo. Andy, thank you so much. You saved me. You saved me. You gave me a second chance, Andy. Gave me a second chance. You gave me a second chance, buddy. Thank you. Right? Because I would have basically found out at the end that, hey, mess up. All right? So I'm sure you guys are seeing that, hey, this is too long. This, that, that, so that's the third one. And then there's a fourth one. Okay? Let's move on. X to the power negative n. Let's see our negative n's there. Only the ones with x to the power negative n. X to the power negative n plus x to the power negative n plus another x to the power negative n plus another x to the power negative n. Okay. Then let's move on to the next one. X to the power m is already sorted. X to the power 2m. Let's check your x to the power 2m's. Let's collect all of them. This one, 1, 2. So it's x to the power 2m minus x to the power 2m. Then let's move on. X to the power minus n plus x to the power m minus n. Now m minus n, where are we? Where m is positive and where n is negative. This one also qualifies. Plus x to the power m minus n. Because remember, addition is commutative. This m is positive, this n is negative. So it's the same thing as that. Those are like terms. Anywhere else? Yes, there. No. Ooh, let's check this out. What happened here? Negative, positive, 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 negative, negative. That was m plus n. Now let's just go back to the actual page so I can check the question out. I just want to check that I wrote it out correctly. Okay, x to the power negative n plus x to the power negative n plus x to the power 2m minus x to the power 2m plus x to the power minus n plus x to the power minus n. I just want to check here, sorry guys. If I multiply the 1 with the 1, I get positive 1, right? Which is good. 1 times x to the power m is x to the power m. Sorry, 1 times 1. 1 times negative x to the 1 times negative x to the power negative n. Done. X to the power, this, that's fine. X to the power m plus m is 2m, that's fine. X to the power m, x to the negative x to the power m times negative x to the power n. So we have positive, and then after that we have positive m minus n. So this is supposed to be minus n. M minus n is m minus n. Now I understand why. Okay, so let's go back to my m minus n's. So I have minus n, I have that m minus n, I have another m minus n here, and then my last one minus x to the power negative n plus m, which is the same thing as m minus n. Just say m minus. So let's look at x to the power negative 2n. So x to the power negative 2n, I only have that x to the power negative 2n and that x to the power negative 2n. So it's plus x to the power negative 2n minus x to the power negative 2n. Guys, do you see that I actually made little errors and mistakes myself doing? So accuracy is of utmost importance. Now, let's add 1 minus 1 is 0. Now, remember, with variables, when you are adding them, x to the power m plus x to the power m 4 times. 1, you keep all x to the power m, you add the coefficients. 1 plus 1 plus 1 plus 1 is 4. So it's 4x to the power m. Let's come here. Same thing, 1 plus 1 plus 1 plus 1 is plus 4x to the power what? Negative n. Okay, so we are done with the 4x to the power negative n's. It's 4x to the power negative n. Let's move on. X to the power 2m minus x to the power 2m, that is 0. Unfortunately or fortunately, x to the power minus m plus x to the power minus n minus x to the power minus n minus x to the power minus n. This plus that gives me 2 of them. Minus that gives me 1. Minus that gives me 0. So from this here, I get 0 as well. And then last but not least, what's x to the power negative 2n minus x to the power negative 2n? I'm subtracting the same thing here. That also gives me 0. Finally, I have 4. Okay, for what? X to the power m plus 4x to the power negative n. What you should then notice is the common factor for x to the power m plus x to the power negative n. This 4 here, guys, is a number that is divisible by 2. So I've just shown or proved, because remember, what did I say to you guys? I said something that is divisible by 2 is your even numbers. Okay? So that means it doesn't matter for any real value that I am going to put in here. Doesn't matter any real number. Whatever I get inside this bracket, the minute you multiply it by 4, all right, it's obviously going to be like that. Or you could do this if you really want to. You know that 4 can be written as 2 times 2. So that means you can write this 2 outside, distribute this one. 2 to the x to the power m plus 2x to the power negative m. So since there's a 2 on the outside, you see, this is a number that is divisible by 2. You know? Remember, if it's an even number, it's going 2 times anything is an even number. Does that make sense, guys? 2 times anything for all real values of m and n. For all real values of what? Of m and n. That means m and n can be any real number. Whatever you get outside this bracket multiplied by 2 is going to be an even number, and that even number is divisible by 2. Okay? I think I'm going to end right there, guys. That was quite long. All right? That's one way of doing it. The other way of doing it, and I just want to, I'm not going to do all of it. I'm just going to expose you. Okay, so when you know maths very well, you will see that, oh, this is actually a situation that shows us a difference of what? Of 2 squares. A what? A difference of what? Of 2 perfect squares. So that means I can factorize this thing. How? The square root of this, right, which is 1 plus x to the power m plus okay? Does that make sense? Then obviously your first term is 1 plus to the power negative n. The square root of the first term is your first term in each bracket. Okay? Then what do? We write a plus in one bracket, we write a minus in the other bracket. We take the square root of the second term, all right, which will give us what? 1 minus x to the power m minus x to the power negative n. All right? Yeah, the network is really doing the things now. I'm sorry, guys. I'm really sorry. The network is not good. So what I was saying is that the other approach is you could actually look at this in light of the fact that this is a difference of 2 perfect squares, which means we can factorize the expression. How? The square root of the first term, okay, will give you 1 plus x to the power m plus x to the power negative n. So you write that as your first term in each bracket, 1 plus x to the power m plus x to the power negative n, because the square root of the first term is this. You multiply these two together, you get this back. Then you open two brackets. The other, you write a plus, you write a minus. The second term in each bracket will be the square root of the second term. So if you take the square root of this, you get 1 minus x to the power m minus x to the power negative n. That's your second term in this bracket and in that bracket. Remember, the first bracket is going to have plus, the second bracket is going to have minus. This is a factorization of a difference of two squares. Then from there, straightforward what you do after that. 1 plus x to the power m plus x to the power negative n plus 1 minus x to the power m minus x to the power negative n. So you can add and subtract the like terms in this first bracket. 1 plus x to the power m plus x to the power negative n. We take this negative sign, we distribute it, we check what we get. Negative 1 plus x to the power m plus x to the power negative n. Then you can add your like terms. Let's check. 1 plus 1 is 2. X to the power m minus x to the power m is 0. X to the power negative n minus x to the power negative n is what? Is also 0. This is my first bracket. What about my second bracket? 1 minus 1 is 0. X to the power m plus x to the power m is 2x to the power m. X to the power negative n plus x to the power negative n is plus 2x to the power negative n. Then, what's 2 plus 0 plus 0? That gives me 2. What is left inside this bracket? 2x to the power m plus 2x to the power negative n. There it is. This is divisible by 2 for all real values of m and n. Finished. So there's the long expanding. Okay? Because maybe you will not see difference of two squares. Or there's the factorizing, where you see difference of two squares and you are able to get the same answer. Okay? Guys, thank you so much. It was great to have the opportunity to be here. Hopefully we'll be able to have more sessions in the future. Please, guys, follow me, follow the creator. Drop roses, drop all sorts of gifts when it is possible. I do love gifts, guys. I am not averse to gifts. I am aware of the fact that this session I've been conducting for the period that I have, I think it's over an hour. Okay, so please, happy to do anything that you would encourage me in the situation that I'm in. Otherwise, thank you so much. I hope you guys have a great day. All the best as you prepare for your final exams. I believe in you. All right, and let us make question 1 of the exam, okay, which can be between 28 marks. Let us make this question an enjoyable one. Let's get the marks so that we can move on to the next and the next question with absolute confidence, so that we can get the marks that we deserve. Thank you so much, guys. I'll see you again. I don't know when, but when I see you, bye.